Hello everyone, my name is Claudio Baldizzone and I am the coordinator of the project RedOxRec from the 2018 Airmen Call. In this short presentation, I would like to give an introduction about our project, a short summary on our main results, and a short overview of our next steps. Let's start with our consortium. In our consortium, we have many different partners. We have large corporations like Bosch from Germany, but also several research institutes, like the Helmholtz Institute from Erlangen in Germany, the National Institutes of Chemistry in Ljubljana, Slovenia, and the University of Antwerp in Belgium. You can find additional information about the consortium and the project in our webpage www.redoxrec.com. Here you can find additional information and all the relevant contacts in case you want to contact us. The total requested funding for our project is slightly above 1,132,000 euros for a project duration of 36 months, from November 2019 to October 2022. In our project, we address the following topics/subtopics: 3.2, increase of resource efficiency through recycling of residues or manufacturing of used products and components; 4.3, recovery of raw materials from end-of-life products; 5.1, new business model. To be brief, our approach can be summarized as following. We want to develop a mild chemical extraction approach for gold and other metals, from fundamental studies to a lab-scale reactor. In other words, we want to find a way to extract chemically the noble metals in the scrap and bring them as ions in the solution by means of mild chemistry. We want then to implement this technology in a recycling process chain, which means we need to address many other topics, for instance, collection, retreatment, and recovery. Where recovery means the recovery of our metal ions from solution back to their metallic form. Our vision is to use this innovative approach as an enabler for decentralized recycling. As many of you know, recycling is an extremely complex topic with several steps and synergies. That is why we decided to split our project in 3 main blocks. The first block is collection and pretreatment. Collection means how we gather, how we collect all the different waste and products and how we bring them to our reactor. And pretreatment means how we pretreat the waste, which means how we disassemble our components, how we size reduce our waste in order to obtain an homogeneous input for the chemical reactor. The second block is the extraction by means of mild chemistry, which means how we extract chemically the metals. And the third block is recovery, how we bring back these metals from the solution back to their metallic form. The first block is the responsibility of Bosch. Bosch takes care also of coordination, cost evaluation, and LCA. The extraction is responsibility of the Helmholtz Institute of Erlangen concerning fundamental investigation, and the developed protocols will be then transferred to Ljubljana, where will then be implemented in a lab-scale reactor. The solution produced by this lab-scale reactor will be then transferred to the University of Antwerp, where the solution will be tested, and the recovery, and in other words, the efficiency of recovery by means of electrolysis will be verified. Here are our current results. I try to be brief due to time constraints. If you have additional questions, please do not hesitate to contact us. Let's start with collection and pretreatment. We used the industrial refuse from several Bosch plants as a use case in order to have a quite well-defined input, and we tested the boundaries of decentralization, which means how decentralized can we be while still being economically competitive. And we developed several strategies in order to reach economy of scales for our process chain. Concerning extraction by means of mild chemistry, the fundamental studies are completed and a leaching protocol has been established. This leaching protocol is currently being transferred to our partners in Ljubljana, where This protocol will be tested in a lab-scale reactor. This lab-scale reactor has been designed, constructed, and optimized in the framework of the project. Preliminary analysis, preliminary experiments using this protocol are currently ongoing. Concerning recovery by means of electrodeposition, the University of Antwerp designed and constructed an electrodeposition flow module, and optimization by means of model solution is almost complete. Concerning the cost evaluation in LCA, the calculation framework is completed, and the team of cost evaluation and LCA is currently in contact with the other work package to gather all the different input and output parameters. What we plan to do in the next few months is the following. Concerning collection and pretreatment, we want to transfer our approach to other product groups, which means we want to extend our approach from industrial refuse to other end-of-life products. Concerning extraction, we want to verify our leaching protocol in our lab-scale reactor using real samples provided by Bosch. Concerning recovery by means of electrodeposition, we want to test the solution coming from our lab-scale reactor and test the efficiency of recovery by using real leaching solutions. All the input-output parameters provided by the other work packages will then be transferred to our cost evaluation LCA team, and an economical and ecological assessment of the recycling process chain will be then provided. Our expected outcome is the following. Depending on the project results, we would like to transfer as much as possible of what we learn within Bosch into its partner, and hopefully to as wide as possible audience. With this, my presentation is over. I would like to thank you for your attention, and again tell you that if you need more information, do not hesitate to contact us. Again, thank you and have a nice